fundamentals of the LTE architecture by first looking at some of the driving factors behind LTE. We'll then move on to look at the LTE network architecture itself. So just considering some of the driving factors, now there are many driving factors for deploying LTE, but we're just considering 3 in this session. Starting off with speed and volume. There is an insatiable appetite for mobile broadband out there at this present time. High capacity and high data rates. And with respect to data rates, from a downlink perspective, with the latest LTE advanced specifications, theoretically, we're looking at about 3 gigabits per second in the downlink. Now, the practical reality of this is completely different. LTE Advanced is in its infancy. But there are many other factors which contribute to the ultimate downlink data rate that a subscriber would expect to receive. And those factors will gradually diminish that data rate till we get down to the reality. The reality of downlink data rates in LTE around about the 50 megabits per second mark, could be higher, could be lower. It depends on many different factors in the network. But in these early days of LTE, even with a 50 megabits per second connection, I would ask, well, what services actually need 50 megabits per second in the first instance? Indeed, even if we just get 20 megabits per second, there are not many services which demand such a high data rate. It's not just about speed though. Volume is significant as well. And this diagram shows the prolific rise in data volumes that are passing over LTE and indeed mobile networks in general. You can see that that rise is set to increase significantly, largely attributed to things like video-based services. So it's not just about delivering speed in the network, LTE is about delivering capacity as well. Another significant factor associated with deploying LTE though is the general move towards IP services, whether that's things like voice over IP, IPTV, or indeed instant messaging over IP. Well, in all those cases, and in LTE in general, all services are IP based. So all services arriving at and leaving the LTE mobile device arrive and leave as IP packets. Now, the whole migration to IP has been in evidence across the past decade in cellular networks. Moving towards IP transport networks gives cost savings to the service provider ultimately. The final driving factor that we're going to briefly discuss is network optimization. As you can see from the diagram, LTE affects the network in general in a lot of different areas. And these areas can ultimately lead to cost savings for the service provider. Whether it's optimizing the way in which traffic is transported around the network, or whether it's optimizing from a policy control perspective, how network resources are actually used. In all of these scenarios, they all have a positive influence on network optimization. So let's take a look at the LTE network architecture itself. Now, LTE is designed to provide connectivity between a user equipment and a packet data network of some description. So in early LTE deployments, that's generally the public internet. But it could just as well be a corporate LAN of some description, or indeed an IP multimedia subsystem. And this is what you'd expect to see for voice over LTE services. So where traditionally GPRS would provide that connectivity, LTE steps in. And there are 2 areas of the network at the highest level that we can consider for LTE. Those would be the RAN, which is called the Evolved Universal Terrestrial Radio Access Network, or EUTRAN, and the core, the EPC, or Evolved Packet Core. Collectively, they form our LTE network. Now, in terms of what's in these different network elements, in the RAN, we encounter the evolved Node B. And this is the only element that you'd expect to see in the eUtran. The Evolve Node B is there to manage the air interface. It will look after things like scheduling, handovers and security. As we move closer to the network, we encounter the first evolved packet core device. This is the serving gateway, and this is for anchored mobility between the eUtran and the EPC. So as we move around the eUtran, our eNode Bs will feed user plane traffic to the core using the serving gateway. As we move further into the core, we encounter the Packet Data Network Gateway. This is our connectivity between the Evolve Packet Core and the Packet Data Network. And collectively, the eNode B, the Serving Gateway and the PDN Gateway form our user plane, as we will see shortly. So this is all user plane orientated at this time. We need control. And the controlling element of this network is the Mobility Management Entity. This device looks after mobility management and session management. So it tracks a user's mobility, but it will also govern the establishment of our data bearers. And supporting the MME will be the Home Subscriber Server, which is akin to the HLR. It is a central repository of subscriber information. As I just mentioned, in terms of the actual data bearer, well, the terminology is the Evolved Packet System Bearer. The Evolved Packet System is the end-to-end network, which includes the mobile, the RAN and the core. And I mentioned that the devices involved in the data bearer would be the eNode B, the Serving Gateway and the PDN Gateway. So every subscriber that is attached to the LTE network will have one or more EPS bearers just for their traffic. Now we do need to consider peripheral elements of LTE. So for a functioning LTE network, what you typically also see deployed is an IP multimedia subsystem. Now this is particularly relevant to VoLTE. So there are lots of LTE deployments that are out there that don't have an IMS, but as these LTE networks start to roll out voice over LTE, IMS networks are also deployed alongside those service provider LTE networks. And part of the VoLTE equation, in order to govern the usage of bearer resources in the network, policy and charging control is also being deployed, so the service provider has got very, very granular control over the traffic that flows over the LTE network. So just in summary then, we talked about some of the driving factors for LTE in this session, and they included the whole notion of accommodating the vast speed and volume requirements that are out there today. We also talked about the whole concept of migration towards IP-based services and the notion of network optimization. We talked about the end-to-end architecture, which included the Evolved Universal Terrestrial Radio Access Network and the Evolved Packet Core, which collectively provided connectivity to a packet data network of some description. That connectivity, remember, was called an EPS bearer. We saw that the eUtran contained the Evolve Node B, and we also considered the Evolve Packet Core, which contained the Serving Gateway, the Packet Data Network Gateway, the MME, the Mobility Management Entity, and the Home Subscriber Server. And finally, we said that it's not just all about LTE. There are other architectural requirements that might be involved, including an IP multimedia subsystem and indeed policy and charging control.